In this video, we're going to go through how to calculate the wavelength necessary to emit an electron from calcium metal. And so calcium metal has a work function of 2.87 electron volts. So the first step that we want to do is to convert electron volts into joules because it's a much easier unit to work with. And so 1 electron volt is equal to 1.602 times 10 to the negative 19 joules. So to do the conversion, what we will do is multiply 2.87 electron volts by 1.602 times 10 to the negative 19 joules and divide that by 1 electron volt. We will see that the electron volts cancel out, and our final answer will be 4.60 times 10 to the negative 19 joules. Now that we know what the minimum energy is to emit an electron from calcium metal, we can use the equation where energy is equal to hc over lambda, where h is the Planck's constant, c is the speed of light, and lambda is the wavelength. If we rearrange that equation, what we get is that lambda is equal to hc over E. And so h, Planck's constant, is 6.626 times 10 to the negative 34 joules seconds. We'll multiply that by the speed of light, which is 3 times 10 to the 8th meters per second, and divide that by the energy we previously determined, which is 4.60 times 10 to the negative 19 joules. We can now see that the joules will cancel out and the seconds will cancel out, so our final answer for the necessary wavelength is 4.32 times 10 to the negative 7 meters. If we convert that into a more comfortable unit, we can see that it's actually 432 nanometers, which falls roughly within the violet-blue region of the visible light.